Good day, the class. Um, Today, as I promised, we will talk about polynomial functions because polynomials are playing a very important role in many applications of mathematics in the real life. Let's open our MATLAB. Um, let's see how we want to define a polynomial. In MATLAB, when we are talking about polynomials, we are basically talking about the coefficients of a polynomial. For instance, if we want to have, let's say, x to, let's call it even ax to power of 3 plus bx to power of 2 plus cx plus d, then what we want to define, how we define it, this polynomial in MATLAB is defined as a vector of a, b, c, d. So if we have four values in a matrix, it means that it is a polynomial of order of 3. So if we have some missing parts, we are replacing it with 0. So let's see how we are representing it in the MATLAB. So let's save what we are writing as a test 7. In order to define polynomial, let's say polynomial y of this form, which is 4x cubed minus x squared plus 3, we define y to be the first coefficients is 4, as you can see. Then next one is minus 1. For x we have nothing, so it's 0, and the constant is 3. And then we are, let's say we want to find the roots of this polynomial. In order to find the roots of this polynomial, I say r is equal to roots of y. Now if I run, it tells me that the roots, we have 3 roots. We were expecting to see it because we had the order of 3. So if we have order of n, we will have n roots. They can be repetitive, but we will have n roots. Here we have the order of 3, and the roots are given. As you can see, 2 of them are complex and 1 of them is a real number. Now, sometimes we have the roots in our hand. For instance, I already know what are the roots. I can define, let's call this one r1, so I can define r2. I want to have a polynomial whose roots are minus 1, 0, and 1. Minus 1, 0, and 1. Now, and what I will do, I will write the polynomial p is equal to poly r2. Now, let's see how it works. If we run, we see that r2, the polynomial is in this form: 1, 2, 3, 4. It will be of order 4, and then we will have the results to be minus 1, 0, and 1. We can easily test it by writing what are the roots of my p, and it says that the roots are 0, minus 1, and 1. Now we can even test. We have r1. Let's see what are the coefficients of r1. The coefficients is, we write poly. We have the roots of r1, and the coefficients are given as we had in here: 1, minus 0.25, 0, and 0.75. As you can see, the coefficients that we had were 4, minus 1, and 3. The reason that, as you can see, maybe they are not the same in one look is because in MATLAB the coefficients of the first polynomial, the highest term is always 1, so it always written as a to be 1. So a should be always 1. Now, in other words, if I want to make a 1, I have to divide whole the y by 4. So what I will have, 4 divided by 4, 1, minus 1 divided by 4, minus 0.25, and so on. So you can see they are corresponding to each other. Now, Assume we have a polynomial. I have given you the polynomial x with these coefficients. Let's say minus 2, 4, 5, 1, 0, 3, 0, minus 1, 4, 1. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's a polynomial of order 9. And we want to see what will happen if, so it has a form like this. What will happen if I put instead of the x, instead of the variable, let's say number 1. So we want to find out the value of polynomial at a given point. For this purpose, we can say that the result z is equal to polyval. So polyval is a function which we use it. Polynomial value will be calculated. I am giving x and I want to know what is this value when x is equal to 1. So I can always, let's say, comment these two. I select them and then I can either use Ctrl R to comment it, Ctrl T to uncomment it, or right click it and I can choose the comment. So it means that they will not be executed. And I run this one and it tells me that if I put the value 1 in this polynomial of x, then I will have the result to be 1. I can of course put any value that I like, for instance minus 1.5, and I run it. And I am so sure that if you put value 0, we are expecting to get 1 because this is the only constant part that we have and we are getting it. Now let's continue our work by talking a little bit about, now we find out a polynomial. We know how we can calculate the value of a polynomial. We know how to calculate the roots of a polynomial, and even if we have roots, we can find out what the polynomials are. Now, another important thing that usually we need to know if we are talking about, let's say, differential equation is what will happen if I have two polynomials, let's say polynomial p1 and polynomials p2, and I want to multiply them. How can I do it? How can MATLAB helps me? Or if I have the polynomial p1 and polynomial p2, how can I divide these two? Or even moreover, if I just talk about differential equations, what will happen if I have a polynomial and I want to find its derivative, or I want to find its integral? In order to see how we can use these ones, we will introduce a few more comments. Now, let's comment these ones and let's continue. Let me also clear the screen and clear all the variables that we have. Now, I defined a polynomial p1 to be 1, 2, 1, p2 to be let's say 2 minus 1, and as you can guess, this means that this is x squared plus 2x plus 1, and the next one is basically 2x minus 1. Now what I want to do, I want to multiply p1 by p2. So I want to see what are the values of the coefficients, and I know that how many coefficients I have. Minus 1 shows me the highest order, the highest power of the variable x that I have inside my polynomial. In order to find the result of multiplication, I call it, let's say, PM, polynomial of multiplication, I use a function called conv, which is already defined in MATLAB. If you are familiar with signal processing, it basically does the convolution. We are not talking about signal processing, so it's simply multiply two polynomials that we have, and I want to multiply p1 and p2, and then if I run it, it tells me that if you multiply it, as you can see, the highest order should be order of 3. In other words, I should have 4 coefficients, which I'm getting 4 coefficients. So the result will be 2x to power 3 plus 3x to power 2. There is no concept of x minus 1. Now, here, convolution will basically multiply a polynomial or convolve two signals that it has, so it does not understand that the output is a polynomial. It always calculates the result of this multiplication. That's why that the coefficient, the first coefficient, is not necessarily 1. This is something that you might pay attention. Now let's assume that I want to divide x squared plus 2x plus 1 by 2x minus 1. In order to do that, I define, let's say, PD, and I use something which is deconvolution, deconv, which is the opposite of convolution, and I'm dividing P1 by P2. We know that P1 can be divided by P2 simply because P2 has lower order than P1, and if I do it, it says that the result will be half x plus 1.25. Now when we have division, always we want to know what is the remainder of this division. What's the quotient and what's the remainder of this division? In order to do that, we can always write it in this form. I define PQ and also PR to show the remainder, and deconv the P1 and P2. And if I do it, okay, as we would see, the PQ, the quotient, was as we had with the previous comment, and the remainder of the division is what we see in here. It tells us what should be the order. I mean, the order cannot be of course of 2 because we already have done it. The order will be a constant 2.25, and the reason for that, the reason that we have 3 values here is we will have the number of the values, like the number of elements P in PR is equivalent to the number of elements in P1, the bigger one that we have. Here we had 3 variables, which shows that the order is 2. That's why that we have the 3 variables. But we know that 2 of them are 0, so it means that we don't have x squared, we don't have x, and what we have is a constant. These two will be used a lot if you are doing calculus and you want to multiply some polynomials with each other, or you divide them. You can use these comments. Now we will talk about 2 more comments, which is very useful. I am commenting these ones. Also let me add the CLC and clear all at the beginning, so we can all screen. Now I want to talk about what will happen if I have P1 and I want to find its derivative. So x squared plus 2x plus 1, I know if I calculate its derivative, it should be 2x plus 2. In order to calculate a derivative, I call it capital D is equal to, I use something called polyder, which is polyderivative of, let's say, P1. And then let's run it and see what is happening, and we see that it has 2, which means that the highest order is 1, so it's 2x plus 2 as we were expecting. We are seeing it. Now assume you need to multiply P1 by P2 and then find its derivative. One way is that we do the multiplication, and then I am calculating a D2 to be polyder PM, which is the result of the multiplication. And if I do it, it tells me that the result is 6x squared plus 6x. Or in polyder, I could do something like that. I can have the polyder, and then I can write P1 and P2. And if I do so, it will find the derivative of the multiplication in one go. So I don't need to have this convolution function. I don't need to conv the polynomial. So I can, the polyder help me and give me this opportunity of having 2 polynomials in there. It will multiply and give me the result of the derivative. And finally, assume that I want to calculate the result of integral. I put the semicolon so next time when I'm running it I will not have an echo on. I even can uncomment these ones and simply turn off the echo. So we will have the variables but you don't see the output. And then in order to find the integral, for instance, I want to find out what is the integral of P2. So it was 2x minus 1. I know that the result of the integral will be x squared minus x plus c, which is a constant. In order to calculate this result of the integral, I am using a function called, let's call it I1, integral 1. It will be polyint, polynomial integral, polyint, and I call P2. I use P2 so I can see the result quickly, and I see that okay, it is x minus it's x squared minus x plus a constant c. By default this constant c is 0, but assume you want to assign a value to that one. You want to have this constant to be number, let's say 5. So you write here polyint p2 comma 5. Even let me do it separately, so I can have I2 to be polyint p2 5, and when I run it, as you can see, the constant will be placed to be 5. Now we have not talked and we will not talk about the symbolic notation, but just for information you can define a variable sim to be let's say c. So c is your symbol, and then you can have an integral like that, and I call it I3, and sorry, it should be symbols, and then when you run it, it gives you the results of the coefficients in a vectorial form, and we have x squared minus x plus c as a constant. But this is not something very useful because we can always consider a 0, like you don't add anything, and then you can substitute them values. Assume you want to know what is the result of an integral from number 5 to number 10. So what I do, I will calculate I2, I1. I already have I1, so I can define, let's say, result to be. Now I know that I need to find the polyint of this time P1, but I want to calculate the value from 5 to 10 based on the first fundamental theorem of the calculus, and we will use the polyval of this when it is 10 minus the same thing, because I have to find the result of the integral which already polyint gives me, and then I have to put the values at 5 and at 10, and I have to subtract them from each other, and if I do it, this is what I get. This is the result of the integral, because the fundamental theorem was telling me that the result will be f of b minus f of a, given that the integral is from a to b. Here a I assume is 5 and b I assume is 10. Now we will see few more examples of different functions in MATLAB in next lecture. I would like you to go and practice a little bit about these functions that you have learned, and be seeing you in the next lecture.